Welcome back to the panel discussion on maritime partnerships. It's not every day we get academia, industry, government, and journalists under one roof. So let's make the most of it. Oceans are extremely important. They cover most of our planet, 72%, but also bear the brunt of our actions, be it plastic pollution or melting sea ice. IIT Madras, I believe, is the perfect setting to have this discussion, as we are not too far from the sea, and the institute also has a rich history of marine technology. I'll introduce our panelists for the panel discussion. You've already met our speakers, Dr. Ravi Chandran, Professor Ramakrishnan, and Commander Kilidhar. We also have with us Dr. Iyengar. Dr. VBS Iyengar is Member Secretary, Naval Research Board of the DRDO. His professional expertise is in the areas of ship design, autonomous underwater vehicles, and performance evaluation of marine systems. He has about 25 years of experience as a professional, 21 years of which he has spent as a scientist in naval hydrodynamics. Please give him a big round of applause. Next, we have with us Captain Sansar Chandra Chaube. He's the head of ports and shipping at Ambuja Shipping Services. And he joined Adani Ports and SEZ at Mundra as a pilot in 2008 and has since been with the Adani Group in various capacities. He is an advocate for technological advancements in the maritime industry. Welcome, sir. We also have with us Captain T. Madan Mohan. He is the Chief Operating Officer of Ennore and Katapuli ports of the Adani Ports and SEZ, and he has over 33 years of experience as a port marine and logistics professional, including 14 years of seagoing experience as a master mariner. Welcome, sir. From the academic side, we have Professor Krishnan Gotti. He is an emeritus professor in the Department of Ship Technology at Cochin University of Science and Technology. He was a professor with the Department of Ocean Engineering here at IIT Madras until his retirement in 2022. He has over 4 decades of experience in teaching and research in naval architecture and ocean engineering. Welcome, you, sir. So I'll start by giving some questions to the industry experts, to the government, and the academics here. My first question is for the academic in the audience, in the panel. Since he's the only one, I'll ask him to go first. What are some of the marine technologies that are waiting and ready to be translated from lab to the industry? You can speak about technologies here at IIT Madras or in general at other institutes as well.
Panel members. So if you look to globally the area, so first thing I am representing basically on marine transport, marine vehicles. That's my background. And if you look to the topic, marine technology is much a wider area, which covers many things we have heard from the panel experts. So maybe my concentration will be confined to the marine transport sector. And we have already seen that the transport total trade is about 90-95% done through water transport. So it is a major thing. So there won't be a situation when you won't be able to do away with ships. So I mean, the trade will come to standstill. So and all operations. So if you look to the global scenario, see 2 things which are emerging and which are more futuristic are ship automation and another thing is the emission reduction, make it more eco-friendly operation. So these are the 2 major areas if you look to the global scenario. So when it comes to automation, you know that there are different levels of automation. IMO has come up with different categories, 1, 2, 3, and 4. The 4th is the full automation, no man on board. So that is where it's going to be. Maybe it will take a long time to reach there. So standing with initially people with a lot of systems on board the ships getting automated, And without, now most of the engine rooms, I think it is fully automated. You don't need the people there. And many systems are getting automated. So the level goes, but still you need people, seafarers on board. And the next level, maybe more automation and less seafarers on board. And third stage is going to be no seafarers on board, maybe remotely controlled. And the fourth stage is no control, it's fully autonomous. So this is a level of automations going up. There are many advantages and disadvantages with regard to this automation, because if you look to the marine accidents, most of the accidents, a lot of accidents are coming due to human error. Okay, so when it comes to the automation, we expect that part to be, not to contribute to the marine accident. So that is the one of the major thing on the automation side. And when it comes to emission, we know again IMO coming to picture. They have put deadlines for emission control for different ships, new ships, existing ships, and all that, phasing out over the period. So naturally, innovations are coming out using of low carbon fuels, LNG and ammonia, then electric fuel systems, and so there are many things coming up, and use of non-conventional energy for propulsion and auxiliary power requirements and all that. So that is another area which is, so these areas is open. There is a lot of things happening and need to be done to make it, take it forward. That is on the reduction of emission side, when you talk about use of fuels of ammonia, LNG and all that. So naturally, what, the engines to be used, whether the percent engines can be used, and maybe it's used for the biofuel. I think biofuel is used up to 20% mixing and all that. And so that is what is done nowadays. So, and another thing is when it comes to the automation side, you see that the application of artificial intelligence is emerging, which will help in a large way for the automation side. So naturally, autonomous cars are coming up. So what you have to do is, when it comes to the automation, is basically, or artificial intelligence application. I mean, along with that, you say it's machine learning or the deep learning and data analytics and all that. It's all data driven. So that means you need to have a database sufficiently large and more reliable. That means you need to have a pure data to rely on the application of artificial intelligence, which leads to the automation of many systems and also the ship. So this automation, to get the data, how you get reliable data, you can get it from actually the operating ships, the field data, or you can get it from experiments, that's a model test data, or you can get it from reliable numerical analysis. So these are different sources of data. How reliable the experimental, how reliable is the numerical approach. All this data, you get abundant data of that out on various aspects, including the hull form, including the propulsion characteristics, including the motion characteristics, controllability of the ship, many things come in picture. So all this data need to be there to use the application of artificial intelligence and take it to the fully autonomous condition. Okay, so, and when it comes to the emission reduction also, it's not only the fuel which is the major parameter. In addition to the hydrodynamic efficiency of the system, that is how the propulsive system, how can you make it a propeller which is more efficient, and can you make the controllability of the ship more efficient. That means the ship will not respond to unnecessarily to the environmental forces like wind and wave and all that, so which imparts more resistance and more fuel consumption, more emission like that. So, and also mentioned about the ship routing. So that is also important. As you know that when the ship motions are more, when ship is traveling through rough seas, the motions become more. And when the motions become more, the resistance become more and fuel consumption become more, and emission again will go up. That's another aspect of efficient routing. So this also, all the aspects are required for the ship. So These are the general things, and this is with the global perspective. But when it comes to the Indian perspective, see, as discussed here, the ships are constituted by different systems, ancillary machineries, electronics, electrical systems. There are many systems, and most of the systems are being imported now. Okay, so we don't have that. So we have to concentrate on the development of these systems indigenously. If you plan to to make India become a developed country in 2047, so we have to work a lot. So if you look to China, if you look to Korea or Japan, they have all these technologies, ancillary systems, and all the components required have been developed indigenously. So that's how you can take it forward. Plus, you have the manpower and other things. There are many other things I'm not covering because of lack of time. I'm not going to details. Maybe if I get a chance later, we can discuss more about that. Thank you.
I want to ask our industry experts over here, what are the qualities that make a technology transferable to the industry?
I think the first thing when we think about technology is it is not always possible to have totally replaceable technology. Like as when I was serving on some ships which were built Korean ships, and it's a very important thing we have to keep in mind. When we were working on Korean ships, they used to have most of the equipments fitted were Japanese. And now, then I have started when I was piloting ships, I was seeing their ships were built in China, but they were having Korean equipments and Japanese equipment. And now you have ships coming to our ports. We have a look at them. At least not the high end, this you can say radars and all, but what you find is the electrical panels and all the subsystems which are there. They are all now, you can say they are Chinese made. So it we start off trying to replace the entire technology. It's not going to happen. We have to take baby steps, and like some of the low hanging fruits like we discussed, and even commander also informed us, like at least the AutoCAD, the software which is used, we do not have the model testing facilities which are there. Those can be developed. The competency lies with, you can say, with the Indian, whether it's IIT or other institutes, is there. So they have to just come together and at least let us pick up the low hanging fruits which are there. No, and I was there at this thing, the stalls visiting. They are having now. You can say artificial intelligence they are using. I think the biggest use of artificial intelligence would be in predictive maintenance, and it is pretty much possible. Today, the biggest cost for the ship owner is fuel, as far as the operation of vessel is concerned. It's fuel, then it's repair maintenance. And if you give the same spares and consumable to one set of crew, they will use it better. And you give it to a second set of crew, they will not. They will do make a measure of it, and the job will not be equally good. So at least with AR technologies and all, you can train the people. You can have training systems in place where you can actually get the people to the level and get them to work. So it is incrementally we have to move forward. And like the shipbuilding industry, unless until it becomes of a certain size, we will not be able to compete with global players. From one, we cannot go to 10%. We need to first have dry docking facilities. Even today, if I have to dry dock my vessel, there are times when I have to wait 1 month, 2 months. If I have to hold my vessel, if there's a seal leakage, and if there's a, I cannot run the vessel and I cannot dry dock the vessel. So 1 month she is not earning anything, and I'm bearing all the, whether the principal cost, the interest cost, the manpower cost. I'm losing that money. I have to go to Colombo, or if it's not available, I have to go somewhere further off. So even when China and all started off, they had the dry docking facilities. So we need to first put our basics in place. So if we should have huge dry docking capacities, vessels can come in, they can dry dock and they can move out. Once that happens, you have a lot of equipment suppliers, vendors. You are developing a pool of vendors, so that can happen. I think rather than The low hanging fruits will be we are strong in software, will remain strong in software. I think the software part of it, predictive maintenance part of it, these things, institutes like IIT and all, they can take it and they can immediately implement it. That is what I think. If we are trying to go for engines and all, big engines and all, it will not be possible. Those, there are very few engines being made in any case, no? So why will they want to shift their production facility from, say, Europe or China to India? No, it's not going to happen. So I feel, as far as India has a strength in software, we should be picking up all the low hanging fruits with respect to technologies which don't need production capabilities. That is what I feel.
Uh, what my colleague has said is entirely true. A few things I would like to add. See, the shipbuilding industry is a capital intensive industry. Means if you make a dry dock, if you make a ship lift, you have to have workshops, you have to have all the equipment shops available to handle the work. So you need a lot of capital expenditure. Then the ecosystem of suppliers, what he said is that everything we cannot manufacture. That is certainly not required also, not possible also. Like in a Korean ship, you will have Japanese equipment and vice versa. But as long as we have the capacity to manufacture simple things, at least that has to be ensured first. Today, in a lot of areas where as simple things as valves, the industry is overloaded. All the government shipyards are having so many projects. The suppliers are unable to cope up to supply things which are not really so high tech. So that is one of the things that whatever is easily done, let us build up capacity on them. And building up capacity comes along with market forces. It is not possible that you have the capacity and then you don't have business. So it is a combination of so many things put together. Everything has to be assembled together, then only it will work. It's like, sambar has got so many ingredients. One of them is out of tune, means you don't appreciate. Similarly, in the shipbuilding work or the industry, everything has to come together. Suppose I have built the ship, it is ready for delivery, but the echo sounder is not working. So I have to get an echo sounder. There is a delay of 5 days, 10 days, sometimes 1 month. So for the want of a nut, the battle will get lost. That is what we are trying to say, that every player is equally important. Whether it is the yard, whether it is the people, whether it is the ecosystem, whether it is the funding. Nothing is there which we can think of omitting or losing out. That is very critical. And how people make a difference, I'll just give you a simple example which we see almost every day. Airline industry, for example. You had other airlines and then you have Indigo. The technology available with all airlines is identical, down to the nearest nut and bolt. But Indigo is doing much better in terms of functionality, in terms of quality, in terms of punctuality. Why? It is the people which make difference. And people, not only at working level, the big decisions are made at the top level. It is a top-driven approach. Once it is driven with the focus that something needs to be done for the country, then only it will get done. If people have, agendas which are not really focused on what the country needs, if people have focus on something which is little deviating from the requirements of the nation, then the progress will not be good enough. That is what is my opinion.
I want to take this question to Captain Madan Mohan. What are the qualities that make a technology transferable?
Yeah. Thank you, Richa. Thanks to all our professors for the wonderful session and which has set the ball rolling. Now, I will just try to give a different flavor. So, I will try to move a little bit of the ships and come to the sector which the ships serve, which is the port and the trade and industry at large. When we talk about the port, a lot of automation is happening, but but not in India, let's say, but in other countries. Okay, there are a lot of scope to happen in the Indian port sector as well, like automated cranes, loading and discharging, receival and delivery, mechanization. So there are ports in China. Absolutely, there is no human in the entire yard. It's all the activities are being done pre-programmed AI and ML technology, amalgamation of three like terminal operating system, your big cranes, and automated guided vehicles, AGVs, and all battery operated, and that is a way forward. Okay, I think in regarding that, our group is making an attempt in one of our terminals in Adani Virinjam. It's a sort of a semi-automated. So that is a one area I think where there is a lot of scope. It only not only optimizes, it also improves your safety levels. Also, cost also it's controlled, and ships can be turned around faster. The revenue leaks can be addressed, and efficiency levels will go up. So that one area I think we can earnestly look in where our academy and industry collaboration can take place. We can come together, do a sort of uh, either mentorship or sponsored programs where we can work together, share the knowledge, and share the SMEs are there, expertise, uh, identify the problems, and try to give us solutions through tech. So shipping industry has been by and large, very slow in adopting the advancement in technology. Like Komodosa was comparing with the airline industry, which is the immediate peer. It's similar fields basically, but the advent of the technology penetration, what's happening there is comparatively nothing. In early 2000, the ARPA is the only technological advancement in the shipping industry, which is a navigational system. Now things have come to a quite a big way, because ships are basically they are driven by regulation. There are unless regulatory requirements are there, ship owners are not willing to invest anything. They are happy with continue with whatever age old technologies with that, unless regulation comes like Marpol, like SOLAS. So those big bosses comes and tells them even the emission control norms, unless they have to come and push it very hard. And next area again, with regard to the port industry, AI and ML advent, and we are also we introduced analytics, video analytics for a safety purpose, IVMS again for a safety purpose, and a lot of IoT adoption is there for improvement of some sensors are installed, like as Commodore Sob also said, in IoT, and as well as AR and VR and digital twins. So there are a lot of areas to improve that, and have a deep penetration. Sustainability, and with the sword hanging on us, we have to have a carbon neutral by 2050, whereas our group we is targeting 2035 itself. And currently we can proudly say like we are 90% of our electricity consumption comes from the green energy sources. So very fossil fuel, we just 10% only we are using it. And also all our equipments are electrified, right from all the tractors, trailers, even our RTGs, all are running under electricity. So but this is a long way to go, because the scope 1, scope 2, which is under our control, scope 3 is not under our control, scope 3 emission norms. So once a ships which are coming to our port falls under scope 3, once they adopt this, or they are made to adopt this sustainable fuel or alternate fuel, so we can see quite a bit of growth over there. And another thing which is really, which is a lot. We have been trying to promote this Uberization of trucks. When we talk about supply chain, the first mile, last mile is always a problem, and there is a lot of lack of visibility for customers to see where their containers are or where the consignment is, because of the lack of technology is not interconnected. Technology is not aiding them so that they can come and have a look at the one common platform. So, like Uber or Ola or Rapido, they made advent in, four wheelers, even two wheelers. So same thing can be extended, can be, looked into for consignment also. That is another big unregulated sector where the academic, the brilliant minds can come together, come up with a system where that can be rolled out, probably on a POC basis. Industry also will be willing to do that. We tried our best, but there is a lot of resistance because of cartelization, because of, so many other external forces. This will be really game changer. So this is one area, I think, where we can put all our efforts together, and we can make a quite lot of difference in this. And the sustainability have other approach, other benefits in form of, for ship owners, carbon credit and carbon tax. It is being implemented in European sector, where all those, to get all the advantages, they are imposing any consignment use only the carbon neutral transportation means. So because of this, the carbon tax, if you are not complying with this, you have to pay the tax. If you are complying with this, you will get a carbon credit. So this dynamics is also going to play a bigger role. So I would like to sum up, ships, as there is a lot of potential for technological advancement, and at the same time, the sector which the ships serve, the transportation, ocean transportation serve, there also quite a bit of inroads to can be made. Thank you.
I want to take some of these concerns that you all have brought up to the government in terms of reducing emissions, making the shipping industry green, and the environmental concerns of some of these technologies. What is the government doing? We know that many of our buses are electric and they're labeled as zero emissions. But if you look at the electricity, how it is generated, it is still coming from coal. So they are not really zero emission buses that we take in the city. So I want to understand what the government is doing, some of the schemes, policies you have, regulations in addressing some of these concerns that have come up.
Okay, first in terms of energy, of course, if you talk about energy now, government has started with the EV. So when you are talking about EV, it is not only for vehicle of on road; it is on the ship, electric, battery operated vehicles. They are maybe promoting more and more, and also you maybe heard about ANRF. NRF means Anusandhan National Research Foundation. The first first call has been announced only to develop the EV type of operating vehicles, not only from the what is called road, but also on the ship and other thing. And the green shipping is the main important tool they are advocating. So basically, some of the things are not available here, but some of the things are collaborating with other country. Especially, I think many of the shipping now they started with the Norwegian and maybe Cochin shipyard together. Green shipping they have started, and also I remember that there are many other in the Ministry of Shipping. They have made many other avenue to develop not only ports but also shipbuilding. I think that is a major thrust has been given now. So maybe some of the things are partnership based, some of the things are research based. All these things have been initiated by various ministries. Of course, the main thing is a shipping, ports and harbor. In the ports, harbor shipping means only shipping ministry is leading on that. But as a government level, I think the green part of the things more and more it is advocated. Of course, now the policy also may come very soon in that aspect, because our things are planned for 2070 as a neutral. I think for that, many of the vehicles we are planning to go for a green shipping. That is a main task.
They have in fact proposed a 30% subsidy on the
Yes,
cost of
green,
the
green.
vessel. When you see this, they can give you 20%. That's a massive subsidy. So the government is trying to promote.
Yes, yes. Thank you. Yes. Yeah.
And Indian shipyards then stand a chance. Because what is happening is Indian shipyards are competing with China, who have got enormous economy of scale. So if I am building 30 ships, my cost is very different than what if I am building 3 ships. So this difference in economy of scale is a massive, you can say, killer for Indian shipyards. The government has introduced the correct policy of 30% subsidy. Only thing is that is only for green vessels. Now, issue is like the green vessels, on what fuel are they going to run? Is it going to be methanol? Is it going to be ammonia? Is it going to be hydrogen? Or is it going to be a mix of other fuels which is there, biofuel is there? So there is no clarity, and there is still, the jury is still out which will be the fuel system. So like we are building for 9 ships. I am now going for methanol. But I just hope that once the rule kicks in and I have to go for reduction, methanol is available. Because if methanol is not available, only ammonia is available. How do I run my ship? So I have to continue paying maybe carbon tax and like what you were saying, more. So I have to continue paying carbon tax and I will not got benefit from having the green.
Yes, that's a fair point. Yes. I want to hand the mic to Dr. Iyengar because he hasn't had a chance to speak.
But one more perspective which even though it is not my direct work, I was just attending some other meetings and so I'm aware of what is happening in our sector. Directly to answer your question and what the government is doing, and as my colleague co-panelist told, it's also the international regulations which drive a lot of these, what we are trying to do. And as far as these norms are concerned, and you asked about the source of power, essentially what you were asking is in case we are moving to more cleaner sources inside the ship. But what about the origin itself? Now there is, yeah.
Just clarify one point. What was your question? The question was that the batteries, when you use, there is no emission. But the production of battery itself involves a lot of.
So the charging, the power
Yeah,
that comes
charging
from
of-
this core power,
yeah,
right? So it's
there
not
are
zero
two
emission.
aspects.
Yes.
One is the charging of the battery,
Yes.
from where the source is coming, and whether the battery itself is being manufactured using
Yes, that's
clean fuel or green energy or what it is.
But then the end of life of the battery is also another point. So
No, that's one thing. Let us just understand about electric vehicles. When Commander Kelida during his talk also told, the ships, first of all, we are talking about megawatts of power even to, propel a ship of reasonable sizes. Not the kilowatts of power that you're talking about in terms of automobiles. So it's an entirely different scale. So even when we talk about electric propulsion, we are talking about a power source inside the ship which could still be, say, some fuel. It could be ammonia, it could be hydrogen, it could be fossil fuels or whatever. So even when you talk about electric ship and all these things. Having said that, the international regulations are driven towards a concept called well to wake. Of course, the well to wake concept is theoretically understood. When I tell well to wake, suppose a ship is, say, going from port A to port B, and that's, say, point A to point B. It is getting its fuel supply from elsewhere. How is the fuel? What is the origin of the fuel? Where is it? And how is that fuel getting transported? What is the energy efficiency of transporting that fuel? Theoretically, well understood concept, but practically getting these numbers are very, very, this thing. And that's why there's a lot of debate, and these international rules are going to kick in by, say, 2030 or 2035. The debate is not exactly on the theoretical concept itself, but how do we get those numbers right? Which essentially means that we should have a manifest of every ship which is sailing, every tanker which is sailing, and all those things. And that data should be there somewhere. And then you have to have the technology to extract the data, put those numbers. And there's a lot of scope for both theoretical and practical work, including academics and this thing, to actually determine. If my colleagues from Indian Register of Shipping had come, they would have probably given a more detailed view about this well-to-wake concepts. Yeah.
Now we are required, like as a shipping company, to inform the DG shipment how many KL of fuel we have consumed.
Yeah.
What is the distance traveled?
Yeah.
So they are basically measuring the carbon intensity index.
Yes.
And like she was saying, maybe the electric cars are green, but the power used,
Yeah.
coal power, is not green. But what happens is electrification is like a process. Like it starts as a process. Like in our foods, when we started electrification, we used to have RTVs, some of our RTVs and trains running on diesel. So the first process was to get them on electric. So we got electric motors and all fitted and cables and all made. So they started running on electricity. Once that was done, the next step was going to green. Now we have wind energy and solar energy powering the this port operations. So we have now set up huge 5 megawatts this thing, wind turbines. No? That comes second. So this will always, there will be a there will be some lag which is there. The first electrical vehicles, let us take that BB step of having the electrical industry, and then subsequently the power which is there can become green on a way. Like daytime, solar power is available, the chargings can take place to a certain extent. Night hours they can be running for some more. He will advise you, like he used to have certain number of ITVs only per train in the port. So like if he has 6 trains, he will have 36 ITVs. But today when he has gone electric, I think I was shocked. So when he told me that number, they are now having 80 ITVs for the 6 trains, correct?
It's 8 plus 4, 12.
See, when it comes to batteries, so even though you get the charging of battery from clean sources, like wind turbine or from solar, or the charging is coming from that, it is not fully green. What you do with the batteries after 8 years? It's not recyclable. That's an environmental hazard. So battery, people talk about that. What do you do with the solar panels after its life? What do you do with the wind turbines after its life? So it's not purely green. There's a lot of hazard, problems associated with that. So this need to be addressed. It's not even though the batteries, people are saying that it's a green technology. The charging may be the only thing you're shifting the location of pollution. That's it. So it's not that it's going to be green.
In fact, I remember when you were saying, if you take the Indigo airline ticket, it says 90 kilograms of carbon dioxide or 100 kilograms of carbon dioxide produced during your travel from city A to city B. So like that, it is going to be there for all vessels.
In now airlines are also offering carbon offsets, but if those offsets also they are learning that they are not really working. So
Of course, the other thing is about you told about alternate fuels. That is the other thing. I mean, there's a lot of potential for hydrogen. Of course, Cochin Shipyard has built a hydrogen vessel, at least as a concept, and something is happening, and all the shipyards are also trying the hydrogen technology. But it still has not addressed the question that you are primarily asking. We are not sure whether it's green hydrogen or grey hydrogen. We are not still sure about it. And to me, I mean, in a public forum, I not make something beyond that, but we are still not sure whether it's green or grey hydrogen.
Grey and black actually.
Yeah.
Black and brown hydrogen also. The cost of producing the emissions.
In effect, I can reduce the emissions to the ship, but I'm not sure about the source.
I mean, it's not related to green energy. So just 2-3 points which I've noted. One thing we addressed is about the software. Basically, we know that we are users of software. We are not generating software. So that's a big problem. But it used to be not the situation. If you look back a few years, maybe 2-3 decades ago, IIT, I know IIT Madras. I also did PhD from here a long time back. So we have generated softwares. So to estimate wave forces, to body motions, and many things, softwares are being used, very used. So these softwares were not marketed. So it was used for the research purpose. Okay. So that is a lack of on our side, because the potential of its market or selling it was not, we have not looked into it. Now the new generation, since the softwares are available, which are mostly developed abroad, the students, even the PhD scholars, rely more on these commercial softwares. That is an unfortunate development. So if we initiate the system, educational system to develop the softwares, with including faculty and students taking interest in that. It is not difficult to get our own softwares, which should be useful. And once the software, the basic code is available, we can go for any modification and use according to our requirement. So that is required. So for that, new funding is required. So I just checked yesterday about the research funding, World Bank data. It was given in 2020. So Indian contribution to research is 0.65 percentage of GDP, whereas Israel is spending nearly 6% of the GDP for research. Most of the developed Western countries, they're spending more than 3% of the GDP for their development. So one should understand sufficient money need to be spent for the research activity. If you are talking about development, if you are talking about developed country, if that's your vision, so that need to go up. I think this is a 2020 data. It might have improved for India over the period. I hope so. And another thing is what I think is all the research should go beyond any, at least the funded research should go beyond the academic interest. It should be product oriented, not making immediate product, but in the long time, you should reach a product. So that is the thing, that then only you becomes a responsible research and become, I should say, useful research. So that should be there. That should be the thing. One should look into that instead of just doing research for it's okay creating PhD or MS scholars and by research is fine, no problem. But if you are funding a project research, it should lead to a product development.
Yes, I have a question follow up to that.
Just add to what Professor Krishnankuti has told, and Commander Kelidhar was also telling about core design capabilities. And if I have to have a sustainable core design capability in this country, I cannot limit it to designing for maybe the Indian shipyards. Of course, we have to do it for Indian shipyards, but it should be for the global market. Today, the fact is that we are not able to compete, or in the economic sense, we are not competitive enough only because of this particular cost of the software. As we appreciate, all the softwares have mainly shifted to subscription model instead of one-time purchase models. So because they have all shifted to subscription model, it is simply accept maybe large shipyards like L&T or Cochin shipyard is affording it for their own in-house. But it is not sustainable for a design house to maintain global competitiveness paying the subscription. Again, academic institutions can still do it because there's a difference between the academic license cost and the professional license cost. So academic institutions can still learn the software, and if I have to break this cycle, essentially what Professor Krishnankuti told, we have to develop the software, and we are also taking all little government schemes which we are having in isolated places. Somehow we have to integrate and make it into this particular thing, and that's the way forward.
Thank you. It's a comment or question from the audience.
Hello everyone. So I'm Dr. Abhilash, a faculty here at IIT Madras. So I probably want to add something to what Professor Krishnankuti has added in context of what happens in Norway. So for example, when Norway, you have these big oil companies which are actually installing big, large oil platforms out there. They are required by the government to invest a certain portion of their profits back into research. So as he was mentioning, we have to invest certain portion of our GDP back into the research. This is a requirement which comes from their side. And when this happens, there is an interesting thing which happens there is that the industry would like to fund this research and also gain something out of it. So therefore, the problem statements are picked by the industry and the academia together. That allows for these so-called problem statements to really gear up towards a product at the end of it. So rather than being an academic exercise, nor being only a product-driven market, they're somewhere finding a zone between them. And several companies have come across. So for example, ZBus is one company which Norwegians have started, which allows people to be ferried autonomously from one side of the Nord to the other side of the Nord. It started off with a funding which happened within NTNU, but then spun off as a company and went past it. And when it comes to software too, for example, wave hydrodynamic calculations. We all see that in the industry, VAMIT is a big tool which uses this fairly often. And that was a spin off from MIT. So it was a professor who started off. ExxonMobil approached him and said that we would like to see how we can apply these for offshore platform design. And they actually worked together for a long period of time to iron out all the kinks to make sure that the product is ready for industry use. And today it is the leading industry use, and the industry doesn't want to shift from it primarily because they have ironed out all the kinks in it. So any new software which comes, you have to go through this process, and there is a hurdle now that people don't want to spend that time in it. So when it comes to doing research and making sure that it becomes a product, there is an importance we have to understand that the industry and academia have to work together. They can't work independently and expect this to work in some sense.
You're absolutely right. And this brings me to my next question, which is how much is the industry investing in R&D?
I think if you really ask me, India is a very, very poor this thing. The investment in R&D is, I think, close to zero. What I can understand. Of course, what we are doing is like the Indigo's example we talked about. It is an exact replica of, say, the Southwest business model, no, airline business model. So we have been replicating things. We have not been investing. In fact, a good thing, and I think the government would do a lot of good to the industry is if they can start like a certain percentage of money has to be spent on CSR. I would say they should cut down by half because I don't know how the CSR really works. I really don't know. But if they can just cut it down to half and say that half of the money can be kept now aside for CSR and half goes to investment in R&D like new technologies, no? Because the industry would be having a lot of problems which they want to get it solved. So that would be a better way forward. But as of today, I don't see any industry. I've been with Adani's and they are pretty progressive and adopting new technologies, getting new systems in place. No, but we are using SAP now. The electric trucks which have come in India, they are BYD trucks which we are using. The cranes are ZPMC, again Chinese, and X, I can name n number of equipments. No, we have set up massive power plants. They were all like Chinese equipments are there or German equipments are there. So I think R&D as such, no, it's a backseat for most. At least I can talk about my own company. I don't see it really into it. It's an execution company. I agree. No? We are very, very good at execution, but R&D is the DNA of the company has to be very different, I think.
Mr. Ramakrishnan has been sitting quietly, so I'm going to put him under the spotlight with my next question. Because you are also leading an Ocean Technology Institute, and because it comes under MOES, you are from the government as well as an academician. So, not all research is applicable or transferable to the industry, right? Does it have to be? Because I think Professor mentioned that it should be thought of with the applicable aspect.
But at least from the R&D institution's perspective, I strongly believe that we should certainly focus on the transferable technologies for sure. And otherwise, the efforts of the individual institutions would certainly go in vain. But from the academic point of view, and also being a professor, I think the fundamental research can also go parallelly. And we try to balance that at times like 50-50, like, the research work that we do, not necessarily to impact the society immediately, that is 50%, but still it may in the long run. But then the remaining 50%, we believe that we should invest our time and effort and resources to see that the problems of the society being addressed, if not today, at least by tomorrow. So that's the kind of methodology that we work on. And I'm sure that is the case with other IITs and NITs as well.
The other way almost do the similar work actually. So when it comes to industry, I agree with Professor Ramakrishnan. One of the things we have to look at is that not all things the industry needs to do. For example, something like Matsya product is basically a specific project for a specific purpose, which we call as technology demonstration or a specific strategic need. These are all one-off projects which essentially industry will look at a sustainable supply chain and all those things. But as Professor Ramakrishnan didn't have time, otherwise he would have brought more examples. For example, he was just telling about underwater telephony, and I'm sure he has more examples about Matsya product. During that time, what is happening is when you look at the supply chain for these things, there are a lot of other ancillary industries which are developing a lot of subsystems which necessarily don't restrict themselves to marine technologies, but also other technologies, or even marine technology not restricted to underwater, but probably other aspects of marine technologies. So when we do projects like that, maybe the whole platform may not be transferable to the industry. It may be like in NAOT or the lab that I was working on industrial, so be it. But the supply chain and the entire thing which got developed or which was encouraged through this project, that is the sustainable thing. So when we look at it, we should not just look at the product alone and whether the product is transferable. Whether whatever we develop through our vendors, whether those vendors are able to use those technology for other markets and sustain. And that's the way to look at.
The exostructure, which part of the Matsya, is also supposed to be of titanium, not just only the spherical form. And that's just it landed in our lab just yesterday. But this exostructure is also of titanium. To be very frankly, we have now only one industry in the entire country, happened to be very interestingly in Chennai, is now capable of doing this entire process of welding. An international certified welder now is available in Chennai, and that is thanks to the Matsya's effort. Had not been this, Matsya, is coined by our ministry and our government, probably we would not have even thought about this kind of industry. Now we have capacity built as a fringe benefit of this Matsya scheme. And similarly, the ADM thickness welding that I'm talking about, the electron beam welding was never there in the country before, but now we have set up exclusively for this requirement. And I'm sure this will also cater for the remaining future as well.
Actually, apart from that, some of the things a government we have a limitation. We want to go some level. That is why industry partners can come and join so that we can take it to another level. Okay, suppose we are having TRL level 6. Now, in order to take it to 7, we will not be able to do because we have not having accessibility to get the material and other things from abroad. But industry people, they can get it very easily when compared to government. So that also sandwiched, that was also very important to develop technology to one level to take it to further level. That is more important.
When we talk about academia industry interaction, it is not confined only to the addressing the problems of industry through academia. And actually, we need to have human interaction between the people. The industry people should have, engineers or who it may be, should interact with IITs, and IIT professors should interact with the industry. We should open a platform, opportunity for that, so that the academicians will come to know what's the problem particular industry is facing and whether it can be taken or solved through research and development activity. And that is one aspect of it. And another aspect is, okay, the reciprocal also is important. The industry people also will come to know that, okay, the institute will have the capability to solve their problem. Another aspect is that the developments need to be conveyed. See, if you develop technology and tell the industry person is not understanding what you're talking about. So he will not be receptive. He said, no, I'm comfortable with what I'm having. I don't want to interact with you and update. So such things should be get rid of. So for which you need to have a continued professional training and interaction for the industry people. Maybe give opportunity for this industry people to have courses or workshops or similar thing, basically a training program. So they will come to know what are the developments and possibilities for interaction and all that. So such type of interaction is also more important. Thank you.
Thank you. That's a great note to end on. Unless there are some questions from this side of the audience, the young folks over here. who've been sitting quietly. Any questions, comments, any concerns you have about industry academia partnerships?
I have just one observation. Okay, my background, I'm Suresh. I'm an Evalak from IIT Madras 91 batch. I spent 15 years in shipyards, 15 years in ports. Now I'm an angel investor and also into maritime decarbonization. My one observation was, as a ports, basically we are supposed to implement the shore supply method for the ships, which is not yet in place, and that could reduce a lot of emissions happening in our coast. So that is something which is wanting. There's a lot of technologies available, green technologies available, both as capturing the emissions from the ships as well as giving them the shore power at the anchorage also. So that's one part of it. So this is one observation which I had. I thought I should tell it. And of course, any kind of thing, the industry is going to accept it unless it is economically viable for them. So it's not just that just because there is a replacement thing, unless it shows its value in terms of economic value, it will get automatically accepted. So that's where the whole interface comes into picture between academia and industry. Now, how do we make it useful for the industry to accept it and give them some kind of incentive to accept it? So that's what is my observation. Thank you.
Any last comments? Any final comments you wanted to make?
First thing is with respect to the investment in basic science. Pure sciences investment is a different thing. When someone discovered electron, maybe 150 years back, no one knew. People must have said, "What is its use?" No? So, but today we know there's thing which we cannot see, but how great a value it has added to our lives. So, investment in pure science is a continuous process, but technology is something different. It has to be because that is what sustains the pure sciences. No, if technology keeps evolving. With respect to the question that Sir has asked, the thing is, we tried this concept of providing shore power to the vessels at Mundra port. The issue is there are vessels which have power requirement from 400 kilowatt going up to nearly 8 to 9 megawatts for larger container vessels, which have got a lot of reefers. How do you cater to such a large power range? No? And because what happens is if you decide to give power, and then the shore power receiving system on the ships are basically meant for hotel loads, low loads. No? And if I have to supply power at 440 volts, the cable will become very massive. No? And if I decide to give at say 3,300 kilovolts, 3.3 kilovolts, it would be small, but then the dangers are there, and the ship has to be ready to receive it. No, so there are plenty of challenges. There's still not standardization of what power the vessels will receive. The once they freeze that, no, say they make it 1.1 kilovolt or they make it 3.3 kilovolts, things will become easier. Another challenge is like we have 50 hertz, the vessels have got 60 hertz. That's another challenge which is there. So there are plenty of challenges, but I think smaller vessels we have, like in our port, which is there, at least the smaller vessels which are coming, they are all onshore power because we can supply them at 420 kilowatts. No? So that's not an issue, and 50 hertz is available. But bigger ships will remain a challenge.
But today there are technologies available.
Yes, technologies are available, but the thing is, the ship owner also has to make an investment on receiving the power at the same voltage and the same frequency, which does not, that's still not agreement in place.
So the problem is basically industry looks for immediate solution, problem solving methods, but they don't want invest on research. So that is a problem. That is our attitude.
Perhaps I'll just.
Sorry, it's okay, sir.
Yeah. So, yes, one point. I mean, one thing probably we left out. No, see, industry has got requirements and therefore problems, and academia can actually have the technology or they can find a solution. But the problem what we are facing is that whatever the solution that academia is giving, industry is not ready to, I mean, it's not possible for industry to directly take it because it needs little more refinement. It has to go to TRL 7, 8 or something like that to go to the industry. Unfortunately, academia is not able to do that. So along with investing, I mean, putting money in R&D to academic institute, maybe industry can think of how do they actually support startups to take this from TRL 3 or 4 to 7 or 8 and then take it to the industry. So that way, if you can, I mean, if industry can find a way to support startups to take these products and then develop it further and then take it, then go to the market, then maybe that may be one of the ways to solve this problem of industry not ready to accept what is coming out of the academic institutes. Yeah, thank you.
Thank you. In fact, Professor Ashok was trying to make one of the points that I was trying to make. Probably just 3 or 4 points that I wanted to make. One thing is, when we are talking about industry academia, generally we are looking at the Indian market. No, we should look at the global market. And how we can fit into, we should identify certain aspects of the global supply chain and try to fit into the global supply chain low-hanging fruits, not the Indian supply chain. And the benefit also will be there in India. There's no point, I mean, because our market size is going to be very, very limited. As Commander Kildare has told, today if I'm talking about, say, less than 0.6%, and then I'm talking about a sustainable model for a company, then I have to look at the low-hanging fruits of the global supply chain, start feeding into that, and slowly add value to the other parts of the supply chain. One advantage we have in marine systems is that the platforms are all 30, 40 years old. What it means is that when I talk about global supply chain, we are not talking about the initial platform, initial delivery, ship delivery, which is shipyards, but also about the long cycle of maintenance, refits, and all those things, of course, and the technologies which are associated with that. Which means that we are also talking about, the things which get replaced after 10 years just because electronics is getting replaced. So these are all huge opportunities actually, considering the upskill and other things. The ship maintenance and refit, and that itself is a huge opportunity. And the supply chain is for maintenance and refit is another opportunity that we have to see in the maritime sector. And the advantage is that regulations keep changing, and if you are able to keep pace with the regulations, then this is a huge opportunity. And the other thing, already Professor Ashokan has made a comment, but the most difficult thing is, yes, academics do up to TRL level 3. Industries, that was your first question in fact. Industries will not look at any technology unless somebody demonstrates that it's already TRL level 7. If I have to come to a working industry and tell, please take it, I mean, apart from these tea room conversations, they will not put their money unless TRL level 7. So there should be something which is taken from TRL level 4 to 7. In the defense sector, somebody is doing it. The Minister of Earth Sciences, somebody is doing it, but those are all for specific identified platforms for strategic or other needs. A similar thing, startups can be one solution. The other solution is a consortium of this thing which is funded, I mean, some Section 8 company which is funded, which holds all these, or which funds all these technologies, which is basically from the CSR fund that you told. I mean, CSR fund is collected by one organization whose governance is governed by companies. It need not be governed by the government. Maybe government can have 1 or 2 representatives. And this company governs this entire ecosystem of trying to lift it from 3 level 3 to. I mean, there could be solutions. I mean, that's a separate debate altogether, but this is required.
CSR funds are the lowest hanging fruit. They need to be split.
So essentially, it is about bringing the academia to also work in some way from TRL level 4 to 7, either as advisors or in some way, which will also, the added benefit is that the graduates from that place also become industry ready when they work from TRL level 4 to 7, which is entirely another thing which we talk in other forums.
No, that's the level where most of the technologies also fail. So, yeah. Okay. Yes. Thank you. Thank you all for showing up today and giving your valuable time for this.